to section 1.2.3. What do they have in common? So we're going to be talking about the family of linear functions. Now, linear functions, linear equations, are going to be written in two main forms for us. Slope-intercept form, the one you're most familiar with, and that's y equals mx plus b. Remember, m is your slope, and your y-intercept is located at 0, b. We're also going to be seeing standard form, ax plus by equals c. Now, with that, x and y are on the same side of the equation, and then c, the constant, is on its own side of the equation, on the other side. Now, with standard form, you're not going to see many fractions. We commonly stay away from fractions when we're in standard form. When we talk about parameters, those are the constants in the equation. So if we have an equation like 2x plus 3y equals 5, our parameters would be the 2 and the 3. Our variables would be the x and the y, the variables, because they change. So what we're going to talk about for problem number 1 is we're going to look at the equations and see what is familiar with them without graphing them. So what we can do is we can look at them into slope-intercept form. Let's get them into the same form. So for the top equation, x plus 2y equals 10, we're going to solve for y. Subtract x from both sides. 2y equals negative x plus 10. Divide each piece by 2. Y equals negative 1/2 x plus 5. Now, we already have y equals negative 1/2 x plus 3. Next, we look at negative 4y equals 2x plus 8. Divide each term by negative 4. And we end up with y equals, now 2 over negative 4 is negative 1/2 x minus 2. And our last equation, y equals negative 1/2 x. Now, if we look at those equations, the slope for the first one is negative 1/2, and our y-intercept is at 0, 5. Now, for our second equation, the slope is negative 1/2, and the y-intercept is at 0, 3. For our third line, the slope is negative 1/2, and our y-intercept is at 0, negative 2. And for our third line, our slope is negative 1/2, and our y-intercept is at 0, 0. Now, if you look, they all have the same slope, but different y-intercepts, meaning if these lines all have the same slope, they are parallel. They would never intersect. And the reason they're parallel, they all have the same slope and different y-intercepts. Let's do the same thing for problem 2. So we have 5x plus y equals negative 3. Subtract 5x from both sides. Y equals negative 5x minus 3. The second line, y equals negative 1/2 x minus 3. The third line, 3x minus 4y equals 12. Subtract 3x from both sides. Negative 4y equals negative 3x plus 12. And divide each term by negative 4. So we get y equals negative 3 over negative 4 is positive 3/4 x minus 3. And then the last line, 5y minus 2x equals negative 15. Add 2x to both sides. 5y equals 2x minus 15. Divide each term by 5. Y equals 2/5 x minus 3. Now, looking at these, the slope is negative 5. The y-intercept is at 0, negative 3. The slope is negative 1/2, and the y-intercept is at 0, -3. The slope is 3/4, and the y-intercept is at 0, -3. And the slope is 2/5, and the y-intercept is at 0, -3. Now, what happens here is none of these lines have the same slope, so they're not parallel, but they all have the same y-intercept, which means all 4 of these lines will intersect at the same point. All of the lines intersect at that point. They intersect at 0, -3. And that's because they have the same y-intercept. That point is on all 4 lines at once, so that's that point of intersection. Let's turn to the next page, please, and we're going to be talking about the graphs and if they're going to be continuous or discrete. Continuous means that they all form a connected line. There's an infinite number of points on that line. Discrete means we're only looking at each individual point. So now we're going to make a graph. So we have the pieces of the bread and how much fiber is in each piece of bread. So I'm going to make a graph. My x-axis, that's going to be my pieces of bread. And my y-axis, that's going to be my grams of fiber. So for fiber, I'll count by 5s. So 0 pieces, 0 grams of fiber. 1 piece, 5. 2 pieces, 10. 3 pieces, 15. 4 pieces, 20. Now, you can see what's going to happen is we're just adding 5 grams of fiber for each piece of bread. So our slope is 5. That's how much we're increasing each time. And our y-intercept is at 0, 0. So our equation, y equals 5x. Now the question is going to be, is this going to be continuous or discrete? Could we have half of a piece of bread? Sure. Could we have a quarter of a piece of bread? Absolutely. Could we have an eighth of a piece of bread? Yeah. So because we can have different amounts of a piece of bread, this is going to be continuous. We can actually keep going in that form. Because you can have even just a tiny little bite of bread, not even a piece, not even a quarter of a piece. So this is continuous. We connect all the points, continuous. Next, we have Killer Fried Chicken. They charge $7 for a basic bucket of chicken and 50 cents for each additional piece. So now if we think the y-intercept, no matter what, we're spending $7. So it's at 0.7. It's 50 cents each additional piece. So the slope is our 0.5, our 50 cents. So our equation, y equals 0.5x plus 7. Now, the cost is y, and x is the number of pieces. So if we were to graph this, I'm going to put a break in the graph because it doesn't start until 7. And we have 8, 9. So we have our basic bucket. So, and then we'll look at how much we're adding for each additional piece. So we start at $7 with no additional pieces. $7.50 for 2 additional pieces. We're at 8, and then $8.50, and then 9. Now, you can't buy half a piece of chicken. They're not going to break that piece in parts for you. You can't buy a quarter of a piece of chicken. So because you can only buy full pieces, this is a discrete graph. It's not going to be connected. Number 5. we have our points. Now there is no context to these points whatsoever. And because there's no context, it's going to be continuous right away. So let's graph it and let's come up with an equation. So we're at 10, 0, 5, 5, 3, 7, 2, 8, 1, 9, and then 0, 10. So our graph, like I said, it's going to be continuous because there's no context. We're not limiting ourselves by only being able to have, ignore the spelling there for continuous. So what we have here is our slope. What we're doing is we're going down 1 and to the right 1. So our slope is -1, and our y-intercept is given to us at 0, 10. So y equals -x plus 10. And that's a continuous graph. No context, we'll consider it continuous. On the next page, once again, no context. This is a continuous graph. I'm not going to graph it, but I will come up with the equation. Now, unlike the last problem, the points aren't working out as nicely. Now, we can just pick any 2 points. I'm going to pick 0, -7, 2, -2. And between those 2 points, I can find the slope. So we have y sub 2 minus y sub 1, x sub 2 minus x sub 1. So for our y's, -2 minus -7 over 2 minus 0. -2 minus -7 is the same as -2 plus 7, which is 5. 2 minus 0 is 2. So there's our slope, 5/2. Now, we don't have to solve for the y-intercept. Remember, for the y-intercept, x is always 0. So that 0, -7 is our y-intercept. So we can write our equation, y equals 5/2 x minus 7. And there is our equation. Problem number 7. James planted a bush in his yard. The year he planted it, the bush produced 17 flowers. Each year, the branches of the bush split, so the number of flowers doubles. The input is the year after planting, and the output is the number of flowers. So the years, so that's x is the years, that's our input, and y equals the number of flowers. Now, can we have half of a flower or a quarter of a flower? No. So because of that fact, without even graphing it, this is discrete. Now, if we think about a table of values, if we start off in year 0, our very first year, we had 17 flowers. In year 1, they double, so it's 34. In year 2, they double again, 68. In year 3, they double again. We're going to be at 136. And they're just going to keep doubling. So if you were to graph this, our y-intercept's up here, and then it doubles, and doubles again, and doubles again. It's not going to be linear. This is not linear. So we're not going to come up with an equation for this right now. It's not linear, but it is discrete. We don't want to connect those points because we can't have half of a flower or a quarter of a flower, any piece of a flower. Number 8, once again, we have just a collection of points, so right away there's no context, so this is going to be continuous. And that's really going to be the basis of how to decide if it's going to be continuous or discrete, is based on what the context is. Now, if I plot these points, and try labeling those again. I didn't go up quite high enough, so that's would be 10, and that'll be 20. And for x's, so we're at 10, 1, so we're about here. We're at 5, 2, so about there. 4, 2.5, about there. Over 2, up 5, so let's say we're about there. Over 1, we're at 10. Over 0.5, we're at 20. So you can look, if we were to connect those with a line through them, that is not a line, it's a curve. So this is not linear again. And for our last problem, without graphing, we're going to decide if it's linear or not. So what we can do is we can pick 2 points. I'm going to pick these 2 points, and I'm going to find the slope. If it's linear, the slope between 2 sets of points should be the same. So for our slope, m equals y2 minus y1, x2 minus x1. Negative 7 minus 0.5 over 4 minus 1. So the slope is going to be negative 7.5 divided by 3. And that's going to be negative 2.5. Next, I'm going to work with these 2 points. So the slope, once again, y2 minus y1 over x2 minus x1. Negative 34.5 minus negative 22 over 15 minus 10. So that's going to be negative 12.5 divided by 5. So that would be negative 2.5. So that's the same as well. And we can do one more check. I'm going to use these 2 values just to make sure. y2 minus y1, x2 minus x1. Negative 22 minus negative 7 over 10 minus 4. Negative 15 over 6. And negative 15 divided by 6 is negative 2.5. So you can see the slope is the same between any 2 points. So this is a linear relationship. So keep in mind the difference between continuous and discrete. Continuous, we connect the points. Discrete, we do not connect the points. For it to be linear, the slope has to be the same throughout the line. So if you pick any 2 points and another set of 2 points, the slope should be the same between them. That's it for section 1.2.3, and I'll see you in the next video. Thank you.